Alright, let's break this one down like a senior developer. We're implementing the classic string to integer conversion, also known as atoi. It sounds simple, but it tests your attention to edge cases, data types, and boundaries, the kind of details that separate a beginner from someone who actually understands what's going on under the hood. So here's the deal. We're given a string, and we need to convert it into a 32-bit signed integer. That means we're working within a strict range, from negative 2,147,000,000 to positive 2,147,000,000. Anything outside that, and we have to cap it. That's what 32-bit signed really means. The first thing we do is strip away all the unnecessary whitespace. You'd be surprised how many bugs are caused by not trimming spaces properly. If the string starts with spaces, we just skip through them until we find the first meaningful character. Then we check for a sign, either a plus or a minus. If it's a minus, we mark the number as negative. If it's a plus, or there's nothing at all, we assume it's positive. This part is critical because numbers like -42 or +99 should be interpreted correctly without tripping over symbols. After that, we start reading the digits, one by one, as long as they're actually numbers. The moment we hit a letter or a symbol, we stop reading. Everything after that is ignored. So something like 4193 with words becomes just 4193. That's how the original C-style atoi behaves too. Now here's the subtle part: overflow control. Every time we add a new digit to the result, we have to make sure it doesn't cross that 32-bit boundary. Because once you go beyond 2 billion, your integer technically can't exist in that space anymore. So we check in advance. If the next operation would push us out of range, we immediately return the max or min possible value. That's how we handle big numbers gracefully without crashing or losing precision. Once we've read all the valid digits, we just multiply the final number by its sign and return it. Positive stays positive, negative stays negative. No strings, no fancy math, just clean, low-level integer logic. Now, the beauty of this approach is how efficient it is. It runs in linear time. Every character is checked once, and it uses constant space. No temporary arrays, no parsing libraries, nothing unnecessary. It's just pure algorithmic thinking, simple, predictable, and safe. And that's it, the atoi function in a nutshell. Elegant, fast, and completely within 32-bit integer bounds. If you understood every part of this, you've leveled up your fundamentals big time. Follow for more LeetCode solutions.